Okay, so in this part of video we will continue our lecture with example 3. So in the examples we will learn on how to draw the bending moment, shear force and axial thrust diagram for the parabolic. Okay, so based on these examples, you can see that we have 100 meter span of arch. Okay, so which is supported, which is a pin supported at A and B, and this arch is loaded by the point load at point D with amount of 100 kN. Okay, so this load is located 25 meter apart from support A, and given that the h of arch is equal to 16 meter. Okay, so as you can see in this diagram, so they have a few points indicated on the diagram where we have a point E, D, F, C, G and H. So actually before we can draw all the diagrams for this arch, you need to find out all these points. Okay, you need to find out all the internal forces of all these points, and you can see in detail on the solution. Okay, so in the next slide. Okay, for instance, okay, so this is the normal step that you need to start with. Okay, where you need to find out all direction at support. Okay, so I don't want to explain in detail on this part because it's remain the same with the previous example. Okay, so as usual, for every point you need to calculate the value of y, the rise y, and the slope before you can calculate the internal forces of arch at specific point. For instance, here we have a point D, so you need to find out the YD and the angle at that point, and by that you can calculate the value of internal forces, which is a moment, the axial force or the axial thrust, and the radial shear force. Because at point D we have a point load that acting at this point, so you need to consider the two conditions, which is a with load and without load. Okay, for the thrust and for the radial shear diagram. Okay, so you need to repeat the same procedure for others point. Okay, for instance, here at point A, which is at support, you need to find out the y, you need to find out the angle, and by that you can calculate the n and q. But here the moment is not calculated because it's at support, so the moment will equal to 0. And at the point E, you can see that the same procedure, you need to find out the YE, the theta, the M, and N and Q. Okay, so the same procedure, and it will be tedious if you consider more points. Okay, so in order to plot the diagram. Okay, so it's quite impracticable to draw the bending moment, shear force and axial diagram by using this approach. Okay, what you can see here is this is a data. Okay, so that we have obtained by calculating the value of moment, the axial force and the radial shear force at points that have been indicated in the diagram. Okay, in the equation. So this point A, for example, we have their own corresponding value of moment, axial force and the radial shear force, and same goes to for the other points. So if you consider more points, for example, right here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 points here. So you need to repeat the calculation 9 times. So it's quite tedious, and it's impracticable to use this way to draw the bending shear force and radial to draw the bending moment, shear force and axial force diagram for the problem. Okay, so due to that, I have one simplified method. Okay, that you can use in order to get this data. Okay, without considering the point many times, without repeating the procedure many times. Okay, so let's look on the solution. Okay, so this is the solution that I have redo. Okay, so So okay, so this is my handwriting, so I hope that you can see this clearly. So don't worry, I'm going to share this in a Dropbox. Okay, so actually the concept of this solution is based on the method of section. Okay, the cut method. Okay, like we analyze the beam. Okay, so you need to cut the for let's recall what we have done with the beam with the cut section method. So you need to cut the beam into a few sections based on the load and the support arrangement. So we will apply that concept exactly on the arch. Okay, so right here you can see that this is the arch based on the example 3. So and we have a pin support, and they have one point load at the point D. Okay, so based on this load arrangement, okay, and the support condition with a hinge at the point C. So they have 3 numbers of cut section, which is A to D. Okay, so and the range here is 0 to 25 meter, and another range is D to C, which is 25 to 50, and the last range with the last cut section is 0 to 50, which is measured from B. Okay, which the X is measured from B. Okay, so the first 2 cut section, the X is measured from A. Okay, so from A. So and for these last cut sections, we measure the X from B. Okay, so since in the arch they have one more step, okay, as compared with the beam, where the step is about the y-axis, the rise y-axis, and the angle, the slope. Okay, so in order to make it the equation flexible, which is in terms of x, okay, so you need to formulate the equation of y in terms of x and the slope in terms of x, because this parameter will be changed accordingly to the position in arch. Okay, for example, okay, let's we look on the first range, which is AD. Okay, the limit is 0 to 2.25 meter. Okay, so by taking a moment, okay, so we need to consider all the internal forces, which is a moment, axial force, and the radial shear force. Okay, so by taking a moment at a cut section right here, okay, so in this range they have reactions, okay, but here you need to resolve all the reaction and the load into component as usual. Okay, so by taking a moment at the cut sections, we have a 75x, okay, 75x from the vertical reaction, and minus with 78.13, okay, which is this is a horizontal reactions at A, and it will give us a negative moment because it is a counterclockwise, and multiply with the y-axis. Okay, so you can see that this 75 reaction multiplied with x, meanwhile the horizontal reaction here is multiplied by y-axis, which is the rise y in arch. Okay, so and this y-axis we have defined this in this equation. Okay, so which is y-axis is equal to based on the y equation. Okay, so we substitute the value of h and the L and simplify this, so we will get the y in term of x, which is 0.64x minus 0.0064x squared. So we will use this formula at every range. Okay, so this make it the equation flexible for any position x in the arch. Okay, so you just simply replace this y-axis with this equation that we have formulated. Okay, so and by simplify this equation, you can see that we have the equation of moment, and this equation of moment is flexible for any point along 0 to 25 meter. Okay, so and doing the same thing for the axial force. Okay, so you can see here we have nx, which is axial force, okay, in the positive in this direction, minus 75 sine theta for based on the component of a vertical reaction, and minus with 78.13 cos theta based on the horizontal component of horizontal based on the component of horizontal direction. Okay, plus with 100 sine theta. Okay, this is under with load condition. Okay, so you may rewrite this equation, okay, for without load conditions by removing this term. Okay, so we have a two set of equation here. So if you reach at this point D, you need to have you need to use these two equation. Okay, so 0 and before 25 meter. Okay, so you just need to use this equation only. Okay, without point load. When you reach the point D, you need to identify two values, okay, with load and without point load. Okay. Okay, so and you treat the same thing for the radial shear force. Okay, so we have equation for with load and without point load. Okay, so this is based on the equations of with point load. So by simplify this, so I can have two equation here, which is without point load and with point loads. And again, you need to identify both of these case when you reach the point D. Okay, so from A and before point D, you just use this case. Okay, so without point load equation. Okay, so and you can repeat the same procedure, okay, by using the y-x and theta x formula, which is in term of x. Okay, and once you have obtained all the equations of moment, radial shear force and axial force, you may get the data before you can plot the bending moment, shear force and axial diagram. Okay, for example, you can tabulate in this table that I have shown in here. Okay, so the first column is represented for the span limits, so which is A to D, D to C and B to C. Okay, so you may to consider at interval of 10 meter of 10 meter, 5 meter interval. Okay, so and by using the equation, the flexible equation or the general equation at each in each range, you may to get all this data. Okay, so based on this data, you can plot the graph of each diagram. For instance, here I have plot the graph by using an Excel. Okay, so if you know how to use an Excel, you can formulate all the equation that you have derived in this Excel template. Okay, for example, I make it three table here. Okay, the first table is present for the AD 0 to 25 meter, second for DC, so which is a 25 to 50 meter, and the last one is for BC, which is 0 to 50 meter. And you can see that I have formulated all the equation and I have obtained all the value of bending moment, axial force and radial shear force, and by using the tools in the Excel, I can plot all the diagram. For instance, here this is a bending moment diagram for the arch, and this is shear force diagram, and this is the axial force diagram for the arch, which is exactly similar to the solution or the diagram in the slide. Okay, so this is a solution in the slide for the bending moment. This is the diagram for the shear force, and this is the diagram for the axial force. Okay, so if you have a problem regarding with these examples, you may to text me, or you can come to my office to asking further with regarding with this problem. Okay, so I hope that you can try to do some problem in the notes. Okay, so I wanted you to do all this problem 1, problem 2, problem 3 and problem 4. So I want to see once after